The life cycle of a heavy-duty tire begins deep within the bark of the resilient Hevea brasiliensis tree. Expert tappers perform precise incisions to release the milky white latex without damaging the health of the tree.
This organic sap is a complex emulsion of water and rubber particles, harvested drop by drop for industry.
Thousands of gallons of raw latex are collected daily and transported rapidly to prevent premature coagulation and spoilage. Ensuring the purity of the raw material is vital. Please subscribe to follow this incredible manufacturing journey today.
Formic acid is introduced to the liquid latex, causing the rubber particles to clump together into solid masses.
The resulting solid slabs are moved toward the milling station, where they will undergo intensive mechanical cleaning stages.
Heavy rollers compress the rubber slabs to remove moisture and impurities, ensuring a consistent density for the factory. Repeated milling turns the rubber into thin sheets, known as crepe rubber, which is then thoroughly air-dried.
Smoking the rubber sheets prevents mold growth and prepares the raw material for the long journey to manufacturing.
Uniform bales are tested for quality before being shipped to high-tech tire factories across the global industrial network. This massive facility transforms raw organic rubber into the complex engineered structures required for heavy-duty vehicle safety. The manufacturing process begins by breaking down the raw bales to prepare them for the critical compounding phase. Precisely measured additives like carbon black and sulfur are essential for providing the final tire with its strength.
High-intensity Banbury mixers blend the ingredients under immense pressure until a thick, black dough-like substance is created.
Discharged rubber must be cooled quickly to stabilize the chemical bonds before it moves to the next station. Anti-tack solutions are applied to the surface of the sheets so they can be stacked without fusing together.
Steel wires are coated with rubber to form the tire bead, which holds the tire onto the wheel. These bead rings must be incredibly strong, as they bear the intense tension of the tire's internal air.
Calendar machines press rubber into fabric cords to create the carcass plies that provide the tire its shape.
Laser sensors monitor thickness down to the micron to ensure the structural integrity of every single tire produced. The tread extruder creates a precise profile of rubber compound designed for specific traction and wear resistance characteristics.
Extensive cooling lines prevent the tread rubber from deforming as it moves toward the automated cutting station ahead. Automated blades cut the tread sections with absolute precision, ensuring a perfect fit during the final assembly stage.
At the tire building station, all the individual components are brought together to create a green tire. Robotic arms apply the inner liner and fabric plies onto the rotating drum with flawless mechanical repeatability today. Bead rings are locked into position, providing the rigid foundation around which the other components will be wrapped.
Automated rollers fold the plies over the beads, securing the structure together before the steel belts are added.
Steel belts are applied to provide puncture resistance and to help the tire maintain a flat road footprint. The tread and sidewall components are wrapped around the assembly and stitched under pressure to remove trapped air. This unvulcanized green tire has the final shape but lacks the strength and the tread pattern of. Green tires move into the curing department, where they will undergo the chemical transformation known as vulcanization today. Tires are placed into molds, where high-pressure steam will expand them against the engraved tread pattern walls.
Vulcanization uses heat and pressure to create crosslinks between polymer chains, turning soft rubber into a durable solid.
After the curing cycle, the mold opens to reveal a finished tire, ready for the final inspection stages.
Robotic arms handle the hot tires with precision, moving them toward automated systems that remove any excess rubber. Trimming machines remove the overflow rubber from the mold vents, ensuring the tire has a clean, professional finish. Every tire is manually inspected by highly trained experts to catch any visual defects before the automated testing. Balancing machines spin the tires at high speeds to ensure weight distribution is perfect for a smooth ride. X-ray diagnostics allow engineers to see inside the tire, verifying that the internal steel belts are perfectly aligned.
Structural integrity tests ensure the tire can handle the massive weight of heavy-duty vehicles under extreme road conditions.
Laser marking provides every tire with a unique identity for full traceability throughout its entire operational life cycle.
Finished tires are palletized and moved to the massive distribution warehouse for shipment to customers around the world. This inventory represents the final result of a complex journey from a simple tree to a high-tech product. Laboratory testing continues around the clock, ensuring that every batch of rubber compound meets strict chemical specifications. Depth gauges verify that the tread pattern is deep enough to provide the necessary traction and water drainage.
The entire factory is managed from a central hub that monitors every machine and process in real time.
Precise adjustments to heat and pressure can be made instantly to optimize production efficiency and product quality levels. Preventative maintenance is the key to keeping this massive industrial operation running 24 hours a day without failure. Modern tire factories recycle millions of gallons of water every year to minimize their overall environmental footprint today.
Advanced air scrubbers ensure that the facility's emissions are clean and comply with the strictest environmental safety regulations.
Chemical bonding agents are vital for ensuring that the various layers of the tire do not separate under.
Steel cords are cut at precise angles to provide the tire with the necessary lateral stability and handling. A specialized coating is applied to the inside of the tire so it can be easily removed after.
Automated warehouses manage the flow of green tires, ensuring that they spend the optimal time in storage before.
Laser profilometers detect even the slightest bulges or indentations that could indicate an internal structural weakness or flaw.
Endurance tests simulate thousands of miles of driving to prove the tire can withstand long-term, high-speed highway travel.
Thermal imaging helps engineers identify potential hotspots where friction could cause the rubber to degrade prematurely today.
Destructive testing is performed on random samples to verify that the internal bond strengths meet engineering design specifications.
Virtual reality training allows new staff to master the complex assembly processes before they ever touch the machinery. Advanced self-sealing layers are added to premium tires to prevent air loss when the tread is punctured by. Specialized winter compounds and tread patterns are designed to remain flexible in freezing temperatures for maximum road safety.
Silica is a modern secret ingredient that helps tires grip the road while reducing fuel consumption for vehicles.
High-pressure steam is the lifeblood of the vulcanization process and is generated on-site for maximum energy efficiency.
Laser cleaning ensures the mold remains perfectly smooth for every cycle, without using harsh chemicals or abrasive tools.
Due to the flammable nature of raw rubber, and the facility maintains its own highly trained emergency response team. The inner liner is made of halobutyl rubber, which is specifically designed to keep air trapped inside the. Automation reduces human handling of green tires, which are fragile and can be easily deformed before being cured.
Maintaining worker health and morale is essential for ensuring a high-quality product is produced every single day.
The final seal is only applied after the tire has passed every single one of the rigorous tests. Every piece of data, from the raw rubber tapping to the final cure, is archived for total accountability.
Inventory management systems ensure that the factory never runs out of the critical chemicals needed for the compounding.
Protective coatings preserve the tire surface against environmental degradation during the time it spends in the logistics network.
The factory never sleeps, producing thousands of tires every night to keep the world's heavy-duty vehicles moving safely. Sustainability begins at the source, with new trees being planted constantly to ensure a reliable future rubber supply.
Modern plantation management uses soil sensors and drone imagery to optimize the growth of every single rubber tree.
Solar-powered irrigation ensures that the trees receive the exact amount of water needed to produce high-quality latex sap.
Maintaining a sharp knife is essential for making the clean cuts required for the efficient harvesting of latex.
Concentrating the latex reduces shipping costs and provides a more consistent raw material for the industrial manufacturing process. Automated intake systems move the raw rubber bales into the factory with minimal human labor and high efficiency.
Carbon black provides the tire with its characteristic color and essential resistance to ultraviolet light and heat today.
Massive electrical systems power the high-torque motors of the mixers and the hydraulic systems of the curing presses.
Digital labels allow for automated tracking of the tire throughout the entire logistics and sales network globally today.
Advanced computer simulations predict how a new tread design will perform in wet or icy conditions before prototypes.
3D printing allows designers to physically evaluate new tread patterns and sidewall aesthetics in a matter of hours.
Constant monitoring and a culture of quality ensure that the factory's output remains among the best in industry. Cooling cured tires slowly prevents internal stresses that could lead to structural failure during the tire's operational life.
Chemical analysis of the rubber compound is essential for ensuring the vulcanization process will create a durable tire.
Protective films prevent the white lettering on premium tires from being scuffed or dirty during the transport process. Thousands of tires are shipped every day to satisfy the needs of the global automotive and transportation industries.
Heavy-duty tires are the foundation of modern logistics, enabling the movement of goods across every corner of Earth.
In the field, these tires must perform under the most brutal conditions imaginable without any structural failure today.
Retreading extends the life of the high-quality tire carcass, reducing waste and saving resources for the global environment.
At the end of their life, tires are recycled into new products, completing the sustainable circular economy cycle.
Strategic planning ensures that the factory can continue to meet the world's ever-growing demand for high-performance tire products. A clean factory is a safe factory, with automated systems working constantly to maintain the highest industrial standards.
Emergency power ensures that the critical curing process is never interrupted, preventing the loss of valuable product batches.
Dedication to detail is the hallmark of every worker in this complex high-tech tire manufacturing facility today. As a new day begins, the cycle of transformation continues, from natural tree sap to engineered tire perfection. Journey is complete, providing the world with the safety and the reliability needed for modern heavy-duty transport.